much. No one will really know who it is. All right, we're looking at 6-4 notes, and we're factoring by grouping and sum and difference of cubes. So with that in mind, let's go over what our perfect squares are. Perfect squares, things like what? Okay, I'll start with 1. You said 4, then what? If I'm just counting, 3 squared is 9, 4 squared is 16, 25. We should be able to do this, right? 36, 49, 64, 81, 100, 121, and I think we should be really comfortable going up to 144, which is 12 squared. Obviously, there's more perfect squares than that, okay? All right, so this is a difference of squares, and then we're going to end the cubes. That we've talked about difference of squares already. The rule is if you have a squared minus b squared, it is equivalent to a times a. All right, so here it is. I have a square term minus a square term. It's literally a difference because it's a minus sign, a difference of square numbers. A times a gives me a squared back. What's going to give me a negative b squared? 1 positive b and 1 negative b. So b times negative b is negative b squared. And notice there's no middle term. There's no just ab because the outside's negative ab and the inside's positive ab. And that cancels out. So that's a difference of squares. What stands out about a difference of squares is there's only 2 terms and it has to be a minus sign. So first rule of factoring is always take out the GCF. So is there a GCF for number 1 there? Oh, I see. What about 5? So whenever you're looking for a GCF, you want to focus on the smaller of the number. Even though you're looking for the greatest, it's the factor that goes in both of them. So 5 goes into 5 and 80. Now, any variables come out? No. All right, so we've got r squared minus what? I'll wait. If you need a calculator, you can get it out. 80 divided by 5. And you have a w squared with that. Okay, so what should stand out is that I have a difference of 2 terms and they're both squared. So I'm looking for these perfect square numbers, and 16 is one of them. So keep that 5 as your GCF. 2 sets of parentheses. We're really doing reverse FOIL. The r times r gives me r squared. And what gives me a negative 16? 1 positive and 1 negative. Now, there's other numbers that multiply to 16, but why am I picking 4? It's a perfect square, and the reason I'm picking 4 is I want the middle to be 0. So this gives me a negative 4r and a positive 4r. That gives me that 0. Now, how do I bring that w squared into play? Well, I'm going to put it after, but yeah, I just pair it up with that. So r times r is r squared. 4r times negative 4r is negative 16. I'm sorry, 4w times negative 4w is negative 16w squared. So let's talk about this. This is my answer, but I want to show you this real quick. If we were redoing it, just to sort of show, I would keep my 5 here and I would FOIL this. R times r is r squared. The outside is going to be a negative 4rw. The inside multiplies to positive 4rw. And last is negative 16w squared. When I go to add like terms, I wish I could do this right. This would have been a negative and this would have been a positive. When I go to add these, the negative and the positive cancel, and I'm left with that first and that last term. Okay? So if I try to use something like 8 times 2, I wouldn't have gotten 0 for the middle term. So I need that perfect square factor to cancel out. All right, I'm looking at number 2, and the first thing I see is, well, that's not a perfect square. What am I forgetting to do? GCF. So out of these 2 numbers, what do they have as a common factor? 2. All right, so what's left? 36c to the 4th minus what? 1. Okay, so I'm going to say it again. You know, if I have a trinomial that I'm factoring, I'm doing reverse FOIL, maybe with trial and error. But if I see a binomial, and this would be a quartic binomial, wouldn't it? Okay, quartic binomial. If I see a binomial, I'm looking to say, hey, is it a difference of squares? Yeah, 36 is a perfect square, and so is 1. Now, what about that c to the 4th? How do we deal with that? I know I'm going to use 6 times 6. I'm not worried about any other factors of 36. I'm starting with 6 times 6. If I do 6c times 6c, I got 6c squared. So what?
6c squared times 6c squared.
Yep. So I'm always splitting. This power has to be even. I split it into two pieces there. And then -1 is simply +1 times -1. Okay. How do I know I'm done? There's nothing else left to factor. I do want to check since I have a higher power. This is not a difference of squares. This is a difference, but 6 is not a perfect square. So this is my final answer right here. But I do want to point out, why does it work? Because that's -6c squared and positive. There's that 0 in the middle. Okay, same deal. Go ahead and take number 3. Look for a GCF. Clean it up first. What can you take out? I got the 7. Anything else? 1m and 1n? Okay, so I'm left with m to the 6 minus what? 4n squared. Now, if we were just doing GCF, that'd be it. But we're looking for this thing called a difference of squares. There it is, a difference. And I know this is a power 6, but can I split it evenly as 3 and 3? All right, so take a second, think about what you would be putting. If you catch it's a difference of squares, it should be simple factoring. We're basically taking the square root by splitting this in half. And what's the square root of 4? 2. So a plus 2n and a minus 2n. There's your first m to the 6. There's your last -4n squared. The outside, if you're interested in looking at that, would be -2m to the third n, and this would be a positive. So we have to have the same thing, but one positive, one negative in the middle. All right, you go ahead and try example 4. All right, let's talk about this. I'm going with a GCF of 10w. How about you? Do we agree?
Yep.
So w to the 4th minus 1. All right, so I've got this 10w. How did you deal with this? What do we have? W squared, and then what?
Plus 1 minus 1.
Okay, I would mark this wrong.
Why?
You tell me. Not fully, it's not fully factored. Keep looking. Don't fall asleep on me because then you can't see the math problem that we're doing. Oh, there you are. Anybody? I keep talking about looking and seeing if there's a difference of squares. I mentioned up here, when I'm yapping, sometimes I'm actually yapping about something that's going to help you in the future. So my yap about, hey, there's still a power of 2 here. We want to see if it breaks down anymore. Anybody? Well, here's what I see. I got the 10w. Can this break down any further? As in, are there factors of 1 that would add up to 0? Because isn't 0 my middle term? Is this a difference of squares? Well, no, because it's a sum of squares, right? So this I'm stuck with, the w squared plus 1. But this guy, are there factors in -1 that add up to 0? Yeah, 1 and -1. Really? We don't see that, huh? Okay, so sometimes, you take out the GCF, you factor. I'm saying it again, you should always double check if you missed a GCF, but when you have a higher power, you want to see, does it factor again? So this happened to break down again. And I'm going to repeat myself because I get people that are all the time doing this. If someone tried to tell me that this w squared plus 1 breaks down, and you do w plus 1 times w plus 1, this is important because we miss this a lot. There's your w squared, but the outside is 1w and the inside is 1w, and then plus 1. So you've got the w squared plus 1, but these don't cancel. This actually gives me w squared plus 2 of these. So do you see why this doesn't factor? Okay, but there are factors in -1 that add up to 0. So if I would change this sign and do the 1 plus 1 minus 1, this is the idea that these cancel out, and I'm left with that piece. Okay, so difference of squares you've officially seen. Whenever I see 2 terms, I'm looking to see if I can break it down. They've got to be a difference, and they've got to be perfect squares. All right, questions on this? Next big idea are cubes. Now, we are not really comfortable with cubic numbers. We don't use them. So you do want to maybe make a note card. So the cubic numbers, like 1 cubed is 1, 2 cubed is 8. So it's 2 to the third. 2 times 2 is 4, times 2 is 8. Don't get it confused with multiplication. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. Now, a lot of times when we work with cubics, we're seeing these numbers repetitively. But obviously they keep going. 6 squared is 216. 7 squared is 343. 8 squared is 512. 9 squared is 729. And you should all know what 10 squared, or not squared to the third. You should all know what 10 to the third is, which is?
1,000.
Yes. I'm sorry, I was saying squared. These are all to the power of 3. Bless you. So if you guys wanted to write above it, when you have time, you could do 4 to the third, 5 to the third, 6 to the third. We need to be comfortable with these numbers. Now, before I even teach you the rule, I want to take a side step here. Do you have your calculators out? Graphing or regular, I don't care. Grab a calculator. I want to show you how to put a cube root in your calculator. Will you shut my door on your way out? Okay. So I am jumping over here. I have the cube root of 27. So, whoops. If I have my TI-84 graphing calculator, and I don't know how well this is going to show on here. Okay, I think you can see it. On this calculator, what we are doing is to take the cube root. There's sort of a quick way of doing it. You can go into the math key right here, math. And you can see in this calculator, we actually have a cube root symbol. Do you see option 4? So here we go again. Type in the math key. Okay. And then I have my cube root options, option 4, and I just type in the cube root of 27. If it's a perfect cubic number, it will give me a nice answer. If I would take something like the cube root of 29, it's going to give me a decimal. This calculator is not going to break roots down for you unless they're perfect cubes. Okay, so that's one way of doing it. The other method on this calculator, let's say I happen to have like a 4th cube of, I don't know, 250. If I had the 4th root of 256, this one's different. If I have the 4th root of 256, I go back to my math key, but I'm going to use option 5. See how it has the x root? And in option 5, I have to type in that this is the root. Now, when I say root, that little 4 is called the index. Okay, that's if you ever see the word index, that is the root or the radical number. So the 4th root of 256 is 4. All right, so we see how to do that on here. Okay, if you're doing it in a calculator like this or the multi-view, and I think it's important to know this in case you're using this calculator, it's a different method. When I go to type this in, I have to put in the 3 first. Now, on this calculator and the other ones, you have a square root key that's above your square key, but you have an x root key that's above your any power. So square, square root, any power, any root. I hit second, and then I hit that key right there. That gives me the cube root. So this doesn't show it, but the 3 is really the x. So it's not 3 times it, it's the cube root of 27. So again, I have to be thinking ahead. I need the 4th index, so type in the 4, second, and my x root key. It looks like this, and then I would type in my 256. If I do this, if I type in that 4 and I do the square root key, I'm taking 4 times the square root of 256. See how there's no little x there? There's no little index thing. So the square root is understood that there's a little 2 there. If I do this, I get a different answer. So make sure you're using your x root key. If you have the multi-view, which I don't have one of those to show you, you do the same keystroke of the 4 and then the x root, but it pops the root up there, I think, in the multi-view. Okay, can we all handle that in the calculator? So you're not going to have a note card on your test, so if you need to know if something's cubic, you can try taking the cube root in the calculator. Okay, good? And you're not going to forget where that is. Okay, then let's jump back to the notes here. So we're talking about the sum of cubes, and we're going to come back and talk about the difference of cubes. So I'm going to come back up here. There is only a difference of squares. Okay, there's no sum of squares. So perfect squares is a trinomial. Difference of squares is a square minus a square. but you have a sum and a difference of cubes, so we're starting with the sum. So notice I have a cubic number plus a cubic number. Now, this breakdown, we use the term SOAP. So I'm going to write SOAP over here. I'm going to do it sideways so I have room to write. So I'm writing the word SOAP, which stands for same. So S for same, O for opposite, A for always, oops, and then P for positive. So the acronym SOAP helps us set our signs. Sets our signs. Wow. I'll explain that in a second, but write that down. Same, opposite, always positive. I'm talking about the signs as in positive or negative. Okay? Got it? All right, flipping back. So I have this. You have to read sideways. I have a sum of cubes. What I'm going to do is I'm going to break it down into a binomial and a trinomial. There's no work to show here, guys. I mean, I'm going to look for a GCF first, and then I break it down to a binomial and a trinomial. And here's what I do. Remember I said about SOAP? I'm going to use the first sign of my binomial is going to be the same. So there's the same sign as a plus. The next sign is going to be the opposite. What's the opposite of a plus sign?
Minus sign.
Look how smart you are, a minus sign. And the last sign is always positive. Doesn't matter what else is going on, the last sign is always positive. So I've got my sign set. That's what SOAP is, the acronym to sort of help us. We don't have to think about signs. Now, the next part is to rip this apart pretty much. We're going to strip it down to its base. So what is the cube root of a to the third? It's just a, right? When I say the cube root of a to the third, I'm asking you what times itself 3 times gives you a. A to the third. A times a times a. What's the cube root of b to the third?
B.
B. Okay, so you take the cube root of these two terms and you drop it in here. Then we need to build it back up. So this is just like that longhand multiplication. I need that first term times this first term to give me back a to the third. So here's a. What should I have here? A squared. So a times a squared is a to the third. So I take the cube root, I drop it here, I square it to put it in the first term. I need the last term b times the last term to give me back that b to the third. So b times what would give me back b to the third? B squared. And I don't know if some of you remember this, but the other day when we were talking about why you can't distribute powers, I talked about how the first and the last, when you do this, will be the same, but you have the middle stuff. So cube root, square this root, and the middle is the product of the roots, which would be AB. The middle is the product of the roots, which is AB. Okay. Now, most people are going to argue and say, but that's a positive A and a positive B. We set the signs for a reason. So this is the one time you ignore the signs. So how did I always remember that this middle was the product? I just remembered it's in the middle, you smash it together. Like I just took these two things, I smashed them together. That was my middle term. Okay, so let's do a couple of these. First, I need to see that there's only 2 terms. So the 2 terms should stick out when I'm being asked to factor. Next, x to the third has no GCF, so I'm dealing with powers of 3. Y to the third. 216, is that a cubic number? Well, it's on my list, right? Yep. Let's say I don't have a list in front of me. I would just take my little calculator. I would go to math, option 4, cube root of 216, and it tells me, yep, it's 6. Okay. So 2 sets of parentheses. These are the problems that there's no work to show. Got it? I'm going to take the cube root and drop it in here. What's the cube root of x to the... Oh, let's set our signs. My bad. Signs would be same, so plus. The next sign is the opposite, so minus. And the last sign, always positive. So I've sort of got a spot for each thing. The cube root of x to the third, x. What's the cube root of 216? We said 6. And then I'm going to keep the y. Okay, how do I get this first term back? I take my root and I square it. I mean, the first term times the first term should give me back that x to the third. The last term times what would give me back 216? It'd be 36y squared. So if I forget the rule, I should remember that first gives me first, last gives me last, and I think about it. I'm truly squaring each term. Here's one part, here's two of them. What should be in my middle? 6xy. It is the product of x times 6y. 6xy, and the sign's already set. Now, that's it. This is where we stop. I should check if my binomial factors more, but this trinomial will not factor more. I'm going to come back to that. I'm going to tell you why and show you why, because it looks like it does, but I'll come back to that. Let's focus on this. Okay, I'm looking at number 6. There's, I believe, no GCF. You can tell me if I'm wrong. But 64 is a square number, but it's also a cubic number, isn't it? But look at the powers. The exponents are both 3, so I'm got to be talking about a sum of cubes. What? Okay, anyway. So, do 343 and 64 have any common factors? What? Can I divide 343 and 64 by anything? I don't think I can. Okay, but they're cubic, aren't they? 343 and 64 are cubic. So, 2 sets of parentheses, same sign, opposite, and then always positive. Make sure you give yourself some room. Are we okay with the signs? That idea of SOAP. All right. So again, you might want a list of your perfect squares and your cubics on a note card. I want to make sure we know you go to math, option 4, and then 343. The cube root of 343 is 7. So here I go. I'm going to take 7p, and the cube root of 64 r the third is what? What's the cube root of 64? It's 4, and it'd be with an r. Now, you can do this in whatever order you want. My habit is I take the roots, I drop them here, and then I build them back up. That's just how I do it. It keeps it organized for my brain. So I'm going to take this 7p and square it. It's not 7p squared, guys. It's what? 49p squared. That's the mistake. People forget the number. I need 7 times something to get me back 343. Take the 4r and square the quantity to be 16r squared. What goes in the middle?
28pr.
So the product goes in the middle, and the sign was already set. There's that 28pr from 7p times 4r. Okay. Number 7. Well, this says cubic, right? So all of these should be cubic. Now remember, this is going to start getting mixed in eventually. D to the third is a cubic. It's power 3, but is 500 a cubic number?
No.
It's not on my list. If I put it in the calculator, I'm going to get an irrational number. Is 4 a cubic number?
No.
What did I forget to do? The most basic thing. Forgot to look for a GCF. So looking at that 4, can I take 4 out of both of them? What is it?
125.
All right, 125 with d to the third plus what? 1. Okay, 1 is a cubic number, guys. 1 times 1 times 1. So go ahead, take a quick second. Always a binomial times a trinomial. Same sign, opposite, always positive. I don't think I left myself enough room. All right, how do I get this first set, this binomial? What do I do? What am I doing? What's the rule to get this here?
5d plus 1.
But how did you get that? Yeah, it's 5d, and this is going to be a 1, but how did you get this? This is the cube root, right? I take the cube root of the first term and the last term, I drop it in, and then I'm going to square this term. So it's going to be 25d squared, and this is going to be 1. 5d times 25d squared, there's my 125d the third. 1 times 1 is 1. What's that middle term going to be?
5d.
The product of the roots, 5d times 1. Okay, I'll give you a second to try this last one. Okay, I need a GCF out of here. That's the first thing I'm always looking for. So what's your GCF? I tried 24. It didn't work. What else did you use? 3? Okay. Anything else? A 3, a C, and a D, right? So 8C to the third plus, what's 375 divided? Is it 125? Am I good? Okay. 8 is a cubic number. 125 is a cubic number. Both of these have a power of 3. So keep that 3CD, binomial and trinomial. Same, opposite, always positive. So this is why I told you guys at the beginning, you either know how to do this or you don't. You need to do this enough that you have it memorized, that you don't blank on a test, because these should be free points. You don't have to do a lot of hard math. Cube root 2C, cube root 5D. Bring this back by squaring it, 4C squared. Bring the last term back by squaring it, 25D squared. What's the middle? Remember, the middle is the product of the root. So that's why I like to bring the roots down. Everything's based off of that. So you said 10 CD, which I don't have room for. So let me try this again. That was a struggle. Minus 10 CD. Okay. There we go. Now, I know a lot of you want to ignore me and move on, but I want to talk about this. I want to do something more basic like number 7. Why does this not factor further, this 25D squared minus 5D plus 1? Because honestly, this looks like a perfect square. See how you have these powers here? Oh, I know. If I try to factor this, it'd be 5D plus 1. Oh, no, actually it'd be minus 1. And it'd be 5D minus 1. Do we agree that 5D times 5D is 25D squared? Do we agree that negative 1 times negative 1 is positive 1? When I do the outside, I get negative 5D, but when I do the other part, the inside, I get negative 5D. This is negative 10. What do I have? Negative 5. So this quadratic trinomial, remember you're responsible for the names, this quadratic trinomial will not factor as a perfect square. Remember, your perfect squares would look like this. Something times itself is a quantity squared. This does not work. These will not factor. So these quadratic trinomials broken into here will not factor further. Are we all clear? Now, in a more advanced math class further down the line, if this was a degree of 4 and a degree of 2, those will factor as quartic trinomials. We are not doing that. Okay? Okay, flip it over, and now we're factoring a difference of cubes. So I'm going to write the rule, but I'm going to remind you we're using SOAP again. The only thing that's different is the sign. All right, what's the rule? If I have a to the third minus b to the third, I have a binomial and a trinomial. I'm going to set my sign. So this time when I say same sign, what sign am I using?
Minus sign.
Yep, it's whatever sign I was given. So if it's a difference of cubes, I start with the difference. Then the opposite would be a positive. And my last term is what? Always positive. Okay, so take the cube root a, take the cube root b, and then square it. So a times a squared is a to the third. Negative b times this b to the second is negative b to the third. And the middle is the product, but I ignore the sign. I take the product of the numbers without focusing on the sign. Now, I'm not going to take the time to do it today, but if we used our skills from 6-2 multiplying, and we would distribute this a and distribute the negative b, everything would cancel in the middle except for the first and last term. Like, we would do all that work and everything would cancel out. Okay, first, is there a GCF? No GCF, okay? So these are both cubic numbers. That's why you want to have that list. Same, opposite, always positive. All right, cube root of 216.
6.
It is 6, but you do want to double check yourself. So 6x, cube root of 125, 5. Again, you don't have to memorize your cubic numbers. You should be familiar with them, but you can always check them on the calculator. You can always write out a list. 1 to the third is 1. 2 to the third is 8. All right, what goes here? 36x squared, right? Square it. Take that and square it. What goes last? 25. The middle is the product of the roots, which is 30x. Again, this is the one time you ignore the sign because SOAP set our signs up. Okay, next one. This is definitely out of order, but I'm going to leave it. If you rearrange the order, you have to deal with the negative sign. Notice in all these problems that the first term is positive. So if you would rearrange this, you'd have to factor out the negative one first. Okay, but let's talk about how we can deal with this. There is no GCF. Same sign, opposite, always positive. Cube root of 64 is 4. Cube root of w to the third is w. So same pattern. 4 squared is 16. W squared is w squared. In the middle is 4w. That's it. I'm done. This is a classic example of one that looks like it factors down, but the factors of 16, 4 and 4 would add up to 8, so it doesn't factor further. I'm going to say it one more time. If you would have rearranged it and made it negative w to the third plus 64, you can't just switch the signs. You would have to make it negative 1 w to the third minus 64, and it would factor just the same. Our signs would be the opposite, and it all works out. Okay? Say it again. Which one would be? Wait, if I rearrange this, if I rearrange it, I'd have the w squared and then the plus 4w and the plus 16. Yeah, you could rearrange it, but if I rearrange at the beginning, what I'm saying is you have to factor out the negative sign. Did I agree or disagree? Am I answering your question? Okay. So I just want to show you can leave it like that, but you cannot use the SOAP acronym. You cannot use the rule if this is negative. You have to take that out first. Okay. All right, guys, you try these next two, but what should you do first?
GCF.
You should do a GCF. Yeah. All right, so there should be a GCF of 4 and an h here, and that leaves me 1 minus 8h to the third. So make sure that 1 gets in there. Then we keep that 4h on the outside. Don't lose that. And then we go into our SOAP. So same sign, opposite, always positive. Cube roots drop down. Square it to build it back up. Square it again. And the middle is the product. All right, so check it out. Make sure you agree. If you rearranged it at the end, that's fine. Just know if you rearrange this at the beginning, to put it in standard form, you have to factor out the negative 1 first, and then our signs will be the opposite at the beginning. Okay, number 12, I'm taking out a 2, and that is it. So I'm left with x to the third minus 27, y to the third. Okay, then I am breaking it down. So same, opposite, always positive. Cube root, square it, and the number, and the middle is the product of the root. All right, that's what those should look like. So again, you know it or you don't know it. We are following a pattern, a shortcut. Okay? All right, last idea for today. Factoring by grouping. Actually a very simple concept, but I need you to, there's one part that's a little bit more abstract. No matter what, I'm always going to do this. I'm always looking for a GCF. So I know it says step 1, group the first things, but before step 1, GCF. So this one does not have a GCF in it, so I'm going to be able to jump into it. Now, if I have 2 terms, I'm looking for a difference of squares, a sum, or difference of cubes. If I have 3 terms, I'm doing reverse FOIL, a trinomial. But if I have 4 terms and I can't do something with all 4, we're going to group them together. So group the first 2, the last 2, and I'd like you to make this little note on here. Between the parentheses, you need a plus sign. So your grouping will always take the form of 2 terms plus 2 terms. So here is why. When I go in to group this, if I put the parentheses right up against this parenthesis, doesn't that mean to multiply? But I was adding these terms. So I'm really using the associative property here. So there should always be a plus sign because if that's gone, it looks like multiplication. Now, factor the GCF for each group. So you're honestly ignoring this, and you're just doing a really basic, what's the GCF of x to the third and x squared? x squared. Take out that GCF and then show me what's left. Divide both by x squared, I get x minus 1. Bring down your plus sign. So that's it, guys. Just a little GCF problem. Bring down your plus sign. Ignore this. What do these two have in common? A 9. So take out the GCF of 9. And then what's left? We're still ignoring this. X minus 1. All right, at this point, I have two terms. I've got this term. Let me make sure my pen's going to write. I've got this term here, and I've got this term here, right? What do they both have? They both have the x plus 1 in common. So you know how we took out the x squared, we put it out front, and then we knocked it out of both of these? Well, the GCF of these two is x minus 1. I am pulling that out front, and I'm going to redistribute that to the leftover x squared plus 9. That's the abstract part. Both of these terms, here's 1 and 2 terms. Both of these terms had an x minus 1. Now, it's not x minus 1 squared. I was supposed to take x squared times x minus 1. Do you see that I have x squared times x minus 1? Then I was supposed to take 9 times x minus 1. Do you see I still have the 9 times x minus 1? So rather than having my multiplication in two places, I'm saying take x minus 1 times these two terms to get this back. This is your final answer. Notice that this is now multiplication in the middle. All right, let's look at another one. Or actually, let me do this real quick. Let me back this up. If I gave you guys x squared y plus 9y, you guys would tell me the GCF of this is what? Wouldn't you tell me it's y? And when you take that y out of both, what would you need to redistribute the y to? X squared and 9. It's the same thing you just did. You said, hey, they both have x minus 1, which was like the y here. We brought that y out front, which is like the x minus 1, and we redistribute it. So the parentheses are important. All right, no GCF in number 14. Now, remember I said that you always have to have parentheses between, or a plus sign between the parentheses? I don't have that. So that little minus sign is going to be like a negative sign on the K, and I'm going to put my own plus sign in there. We shouldn't have multiplication, but let me talk about why I need to do that. Let me rewrite this. These little extras do make a difference. So definitely a level of understanding here. If I ignored what I just said, and I grouped it like this, what just happened? That negative sign would distribute to the K and to the negative 5, right? So then I'd really have negative K plus 5. Should that minus sign that was on the K affect that minus sign on the 5? Okay, so you could do addition of the opposite and not distribute it, but I've learned kids distribute, so that's why I say group it, keep the minus sign there, put your own little plus sign. And then we're back to just factoring. These two have a K squared in common, so we're doing two mini factoring problems. So they both have the K squared. What's left? K plus 5. Bring down your plus sign. Now, I have a negative K minus 5. Is there a GCF here? Just, okay. Normally, if the GCF's 1, we don't touch it. I need to take out a 1. You need a placeholder. Here's the problem. I have a positive K and a positive 5. What do I have here? Both negatives. Is that what you're going to tell me? Oh, go ahead. Yeah, so I want to factor out the negative 1 to change the signs. So that's going to leave me now, negative K divided by negative 1 is K, negative 5 divided by negative 1 is plus 5. So sometimes we have to manipulate our signs. I normally leave this one alone, and if I need to pull the sign, I will. All right, you have two sets here. What do they both have in common? K plus 5. Once I factor that out, what's left over? K squared, then what? Minus 1. And then I would mark that wrong. Not because I want to, because it's wrong, people. No, it's not that. Whenever you're done with this, you need to look. So if I go back here, this didn't factor down. That had an x squared, but it had plus 9. There's no factors of 9 that add up to 0. So anytime I have a power, I need to look. This doesn't go down, but do you see this now? Isn't this a difference of squares? So this is sort of what I call that eye opener. Like we think we're done, but sometimes they factor further. So you would get most credit for this, but you missed that final breakdown that it kept factoring k plus 1, k minus 1. So the tip is you always want to check and make sure, do I have a GCF? But the other idea is if I have a power, can it go further? You got to understand that this doesn't work. There's no factors of 9 that add up to 0. All right, let's see if we can knock out a couple more. First thing I'm doing every problem is looking for a GCF. Is there a GCF here? No GCF? Okay, so we're going to group it. Parentheses, parentheses, squeeze that minus sign on the 16. Remember, because minus 16 is the same as plus negative. Then we're going to focus on each group. So factoring by grouping, it's actually a very easy mathematical concept because you're just doing little GCF, but you've got to know the steps and you know, be able to break it apart. Once you get the pattern, you're good. What comes out of these two? Just a v squared, and I'm left with 4v minus 5. So sometimes I can't take a number out. What comes out of these two? Well, I keep my plus sign, and I'm going to go with the 4. But here's the problem. If I take out a 4, I'm still left with a negative 4v, and what do I want it to be? Positive. So I want to switch my sign. So anytime I need to adjust my signs, I'm going to take out a negative number. That leaves me a positive 4v, and 20 divided by negative 4 is negative 5. So if you ever get here and your signs are wrong, you might need to factor out a negative. Okay, what do they have in common? 4v minus 5. I brought that out. What's left over that I'd have to redistribute it by? The v squared and the what? Minus 4. Before you're done, did you check it? This is good, but what about this? There's a power there. Isn't this a difference of squares?
No.
What are the factors of negative 4 that add up to 0? 2 and negative 2. So you keep your v, 4v minus 5, and you break this down to v plus 2 and v minus 2. That's your final answer. All right, try that next one, 16, please.